Okay, today is we're going to be working on lesson 4.6, which is absolute value equations and inequalities. So we're going to talk about how to solve absolute values with an equal sign and with inequalities. So the first thing I have written down here that you want to write down is that the absolute value of a number is its distance from 0 on a number line. So that's a really important idea to remember, that absolute value is a distance. So that's why it can't ever be negative, from 0 on a number line. So if I have right here the absolute value of x equals 3. So really I'm saying it's whatever this number is here, its distance from 0 is 3. So if I have 0 and I count out 1, 2, 3. So one solution is right here at 3. So x equals 3 because 3 is 3 away from 0. But I also go the other way. -1, -2, -3. So -3 is also a solution because -3 is 3 away from 0. So I could put 3 in, and the absolute value of 3 is 3, but the absolute value of -3 is also 3. So those would be my two solutions. So now we're going to look at an equation that has that. So I've got x plus 5, the absolute value of x plus 5 equals 11. So on this problem, we're going to solve this just like it's a regular equation. So I'm going to subtract 5 from both sides because I want to isolate this absolute value of x. And since that 5 is not a part of it, I can just subtract it. So I get the absolute value of x equals 6. And now this becomes just like the problem up here. So I'm looking at, okay, what numbers are 6 away from 0 on a number line? So x could be 6, and x could be -6. So those are my two solutions. So then I go to this next one. The absolute value of a minus 3 equals 5. So same thing, I'm going to add 3 to both sides. So I can get the absolute value by itself, and this equals 8. So absolute value of a equals 8. So my two solutions, a could be 8 or a could be -3, or -8. Okay, so now I would like you to do quick check 1, which is on page 235. Oh, and you can't see that. Hold on here. Quick check 1, which is on page 235. Go ahead and do all of them, A through D. A through D. So pause the video and then hit play when you guys are ready. Okay, let's take a look at these. Okay, so for the first one, you have t minus, absolute value of t minus 2 equals -1. So the first thing that you should have done is added 2 to both sides and gotten that the absolute value of t equals 1. So then your solutions are t equals 1 and t equals -1. That's for the first one. For the second one, you should have had 3 times the absolute value of n equals 15. So on this one, this isn't 3 plus absolute value of n, it's 3 times the absolute value of n. So now you should have just divided by 3. And this is canceled, and you get the absolute value of n equals 5. So your two solutions are n equals 5 and n equals -5. For C, you had 4 equals 3 times the absolute value of w minus 2. So you add 2 to both sides, and you get 6 equals 3 times the absolute value of w. So we're going to divide both sides by 3, so this is a two-stepper. 6 divided by 3 is 2. So the absolute value of w is 2. So your two solutions would be w is 2 and w is -2. Now this part D was an interesting one because it says, is there a solution Is there a solution to 2 times the absolute value of n equals negative 15? Well, when I divide by 2 here, this tells me that the absolute value of n is negative 7.5. Now let's think about that for a second. This is saying that whatever number in here, its distance from 0 is negative 7.5. Can you have a distance that's a negative? No. So this one does not have a solution. No solution. Because the absolute value can't be negative because it's a distance. It has to be positive. So that one is actually a no solution. Okay, hopefully you did well on those. Let's move on to the next one here. So now we've got more than, this is different than what we just saw because here I have an entire expression part of my absolute value, the whole thing. So really this whole expression, we're saying that that is 11 away from 0. So since this is 11 away from 0 on a number line, I need to solve for t plus 5 equals 11. Notice I'm getting rid of the absolute value sign, but I also need to solve if it was at negative 11, because both 11 and negative 11 are 11 away from 0. So you have two things you have to solve when you see these two equations. And when you do that, you take the absolute value away. So now I just solve the first one, and I get 2p equals 6, divide by 2. So one solution is going to be 3. And then over here, I subtract 5, and I get 2p equals negative 16. I divide by 2, so p equals negative 8. And I know I did these right because if I plug these in, if I put 3 in up here, I would have the absolute value, 2 times 3 is 6. So 6 plus 5 is 11. So is the absolute value of 11 11? Yeah, so I know I did it right. And then I know I did this one right because if I put in negative 8, then I would have 2 times negative 8, which is negative 16. And what's negative 16 plus 5? Well, that's negative 11. But the absolute value of negative 11 is 11. So that's why we have those two different values here. So let's look at another one like that before you try one on your own. So again, this expression we're saying its distance from 0 is 9. So I'm going to solve this as if it could be at 9 or negative 9. So I have two paths here. I solve 3c minus 6 equals 9. And I'm also going to solve 3c minus 6 equals negative 9. Okay, so then I'm going to add 6 to both sides. And I get 3c equals 15. Divide by 3, so c equals 5. That's one of them. Now I come over here. I'm going to add 6 to both sides. I get 3c equals negative 3. I divide by 3, so c is negative 1. So those are my two solutions. And again, you could check it, because 3 times, if I check the 5, 3 times 5 is 15. 15 minus 6 is 9. Absolute value of 9 is 9. Now if I put negative 1 in, 3 times negative 1 is negative 3. Negative 3 minus 6 is negative 9, and the absolute value of negative 9 is 9. So those are why my two solutions work. So what I would like you to do is try quick check 2 now, which is on page something. It's on page 236. And I would like you to do A through C. So hit pause and then come back when you're ready. Okay, so here we go. For A, we had the absolute value of C minus 2 equals 6. So the way we're going to solve this is we're going to solve it because it's 6 away from 0, so it could be at 6 or it could be at negative 6. So I'm going to go ahead and I'm going to add 2 first. So I've got C equals 8. I'm going to add 2 over here, and I get C equals negative 4. So that's what you should have had for your two solutions for that one. Okay, for B, you should have done, it was negative 5.5 is equal to the absolute value of t plus 2. This one was a tricky one because on this one, this is telling you that your solution, the distance, is negative 5.5 from 0. And we talked about this before. Can you have that? Can you have a negative distance? No. So this one was actually a no solution. It's just no solution. And then for C, you had the absolute value of 7D is equal to 14. So we're going to solve that for 7D equals positive 14 and 7D equals negative 14. So you divide both sides by 7. So D equals 2. And divide by 7 over here. D equals negative 2. Okay, so that was solving absolute value equations. Now we're going to look at the second part of this, which is solving absolute value inequalities. And I want you to write down this chart. I'm going to leave this up here for a little bit. And I need you to copy this down. Actually, why don't you, let me zoom this out a little. I want you to pause the video right now and make sure everybody writes this down and then hit play after you have it written down. Okay, so what does this chart mean? Well, I have two absolute value inequalities here. This one has a less than sign and this one has a greater sign. So this is the example, okay? Now I turned this into words, but you're going to see I did a little play on words here to help you remember this. And so since this is a less than, rather than say less than, I put less than, and I underline the word and, because the way that you're going to solve an absolute value inequality with a less than sign is to solve a compound inequality for and. So you can remember it because it's less than. So we're solving the and compound inequality. Now this absolute value inequality has a greater than sign. So see how I took the word greater and I made it greater? So that means you're going to solve a greater absolute value inequality using the or compound inequality. So this one, if it's less than, you solve it using the and compound inequality. If it's a greater than sign, you solve it using the or compound inequality. And these are what we talked about in lesson 4.5. So let's go ahead and look at this so that you guys know what I'm talking about. So we're going to do this first one, the less than first, which means we're going to solve it using this compound inequality right here. So the rule is, and I want you to write down this rule, so when the absolute value of A is less than B, so less than, I'm going to write that above here, less than, and I'm going to do my little play on words there, less than, you're going to solve this compound inequality. So in this example, the n minus 1 is my A. And the 3 is my B. So the way that I'm going to solve this is I'm going to solve negative B, so I'm looking up here. I'm going to solve negative B, so I put in negative 3, because 3 is my B, is less than my A, which is n minus 1, which is less than my B, which is 3. Now this goes back to our lesson yesterday, a compound inequality and inequality that you're going to solve. So you just solve the first half, negative 3 is less than n minus 1, and you have to solve n minus 1 is less than 3. So here I would add 1 to both sides, and I would get n is greater than negative 2. And over here, when I add 1 to both sides, I get n is less than 4. So now I can squish that together, and I would say my solution is negative 2 is less than n, which is less than 4. Now, I want to show you a way that you can check this that works. So I'm going to make a number line here, and I'm going to go -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. Okay, so see how this is n minus 1? So I'm going to look at, since it's n minus 1, I take the opposite of that, which would be n. I take it like it's positive right here. And I'm going to say, okay, what is 3 away on either side? So if I count 3 away this in the positive direction, 1, 2, 3, well, look, here it is right here at 4. And then if I go 3 this way, 1, 2, 3, here it is at -2. And that's my solution. But again, I use +1 because it was -1 here. You use the opposite. So I put a little tag there, and then I just measured 3 one way, 3 the other way. And then I shaded in between because the distance has to be less than 3 from that +1. Okay, so let's look at another less than 1, and this is going to be a less than and equal to. So again, I'm going to use my rule from above that you guys should have written down on your sheet of paper. This is going to be my A, this is going to be my B, and so I'm going to solve it. So I'm going to solve my -b is less than or equal to A, which is less than or equal to B. So I say, okay, I've got -2 is less than or equal to y minus 5, which is less than or equal to 2. I'm just plugging things in. And then I'm going to go ahead and solve this. So I say -2 is less than or equal to y minus 5. I'll solve that one, and I'll solve y minus 5 is less than or equal to 2. So I'm going to add 5 to both sides, and I get y is greater than or equal to 3. And over here I add 5 to both sides, and I get y is less than or equal to 7. I need to squish that together, because this is an and, so I have 3 is less than or equal to y, which is less than or equal to 7. So that's my solution. But again, I'm going to check this. So since this was y minus 5, I take my number line. I just want to make sure I'm not going off. There we go. Okay, so I'll go like 2, 3, 4, 5, 6, 7, 8, 9. And I did that because since it's minus 5, I'm going to put a little tick mark at the opposite of that, which is plus 5. So I put a tick mark here at +5, and the distance had to be less than or equal to 2. So I go 2 on each side. 1, 2, oh, there it is, and 2 on the other side, and the distance had to be less than that. So that's a way of checking. So you can see I was at 3 and 7. Okay, so those were less thans, and now we're going to look at our greater thans. Greater. Okay, so here is our greater than rule. So when the absolute value of A is greater, and I'm going to write greater above that so you remember, greater than B, you're going to solve this absolute, or this compound inequality. And you do have to have these memorized for the test. So this is an OR, so the OR shows up over here, an OR compound inequality. These word plays are just to help you remember which compound inequality to use. If it's less than, then you're going to use and. If it's greater, then you use this OR one. So make sure you have that written down. And we're going to solve this first one, which is actually just like the one we solved, the first one that we solved, only it was a less than then, and now we're doing it as a greater than. So n minus 1 is my A, and this 3 is my B. But since it's a greater, we have to use this rule instead of the other rule. So I'm going to, my first compound inequality is going to be, or my first inequality is going to be n minus 1 is less than -3. So I had to change it to a less than -3. So when I switch the sign to a less than, I made it negative. And then I've got OR Now my a value, n minus 1, and this one stays the same. It's just greater than 3 because it's greater than my b value, which is 3. So now I just go ahead and I solve it. I add 1. So n is less than negative 2, or add 1 over here, and n is greater than 4. And again, you can check this one. So this is your solution, because I would put, so if I have negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. So I put a little tick at 1, since it's minus 1, I make it plus 1, and the distance has to be greater than 3. So I go 3 over 1, 2, 3. There's my one solution, so n has to be greater than 4, because it has to be greater than 4 away. I go 3 the other way, 1, 2, 3, and it has to be less than negative 2. The hardest part about this is remembering what rule, but hopefully the less than and greater will help you with that. So okay, here's another greater, so I'm going to use the rule from above. This is my a, this is my b. So the first rule is to take your a, and then you flip the sign, because this is a greater, so I'm going to use my or. I flip the sign and I make it negative. And the second inequality, you just keep exactly the same. And then you solve each of these. So here I'm going to add 3 to both sides, and you should have b is less than or equal to negative 1. Over here, you add 3, you get b is greater than or equal to 7. So, and this is an or, so we don't squish them together like we did with the and. So then I'll test it. 0, 1, 2, 3, I have to get up here, 4, 5, 6, 7, 8. Okay, so I put a tick mark at positive 3, and then my distance from it has to be greater than or equal to 4. So I count over 4. 1, 2, 3, 4. So then I'll put a closed circle at 7, and it's greater than, so I shade this way, so I know that I did that right. Yep, v is greater than or equal to 7. I'll count 4 this way, 1, 2, 3, 4. Closed circle at negative 1, and v is less than negative 1, so I shade this way. Another way to check these is just to plug in points. So you could just plug in any point that's less than or equal to negative 1, like negative 2, and make sure that works, which it would, because negative 2 minus 3 is negative 5, and the absolute value of negative 5 is 5, and 5 is greater than or equal to 4. Or plug in a number up here, like 10. 10 minus 3 would be 7. The absolute value of 7 is 7. 7 is greater than or equal to 4. So I would like you to try quick check 3 now, which is on page 237. And it's just, go ahead and do, just A. Do just A. So hit pause and then come back when you're ready. Okay, so let's look at A. We're going to do, go ahead and check, watch what I'm doing and check it and see how you did. So we had the absolute value of w plus 2 is greater than 5. So this is a greater, so you're going to use the OR rule. So with the OR rule, the first thing you do is write w plus 2, flip the sign, and make it negative. That's the first one. Or the second inequality is to keep it exactly the same. So then I'm going to subtract 2, and one solution you should have had was w plus 2 is less than negative 7. Or here you're going to subtract 2, and you get w is greater than 3. Okay, so that's it for this lesson. There was a lot of stuff in it. If you need to go back and watch parts of it again, maybe even while you're doing the homework, when you're by yourself, go ahead and do that. And that's it.